All right, we've got two new derivative rules. The derivative of sine x is cos x. The derivative of cos x is negative sine x. And these rules play nicely with all the other rules that we've already done. For instance, if I had something like this, f of x equals x squared times sine x, and I wanted to know what's the derivative of x, well, how do you take a derivative? You got to figure out what derivative rule to use. And how do you figure out what derivative rule to use? Plug in a value for x. If I were to evaluate f of 7, what would I do? I'd do 7 squared, I'd take the sine of 7, and then I'd multiply those two results. The last thing I did was multiply. This is a product. So f prime of x, I have to first of all use the product rule. I've got the first function times the derivative of the second function plus the second function times the derivative of the first function. Right? At some point I'm going to take these derivatives on the fly, but not yet. So here we go. The product rule gave me two other derivatives I need to evaluate. So now I'm looking at just the sine x here. So the x squared sitting there. The derivative of sine x is cosine x. And the derivative of x squared here is 2x. I'm going to opt to write the 2x out in front just because, well, multiplication is commutative. You can write it in either order. But I find that if people write it like this, they say sine x times 2x, and then all of a sudden the x and the 2x are being multiplied together when 1x is inside of the sine and this other stuff is outside. So, don't do it. So anyway, I just find it easier if I can write that out in front. Right? So there's, a product rule with sine and cosine. You could, have a similar, sorry, with sine, you'd have a similar thing, with a quotient rule, for instance. If you've got, g of x is equal to, let's put 3x to the fourth plus 7x divided by cosine x. How do you take the derivative? Well, this is a quotient, right? If I plugged in a value for x, I'd have to figure out the numerator, I'd have to figure out the denominator, and then I'd divide. The last thing I do is divide. So this is a quotient, so I use the quotient rule. I've got a cosine squared on the bottom. I've got a cosine of x right here, times the derivative of the top. The derivative of the top is 12x cubed plus 7 minus the top, 3x to the fourth plus 7x, times the derivative of the bottom. Well, cosine of x is the bottom, so I have times the derivative of the bottom, so times negative sine x. Now, careful here. I see sometimes people don't put it in parentheses, and then it looks like you're just subtracting sine x. You're multiplying by negative sine x. So be careful. And in fact, the minus minus is going to turn into plus. So I've got a cosine x times 12x cubed plus 7 plus a sine x times 3x to the fourth plus 7x, all divided by cosine squared x. Right? Are you feeling any temptation to cross out one of this cosine with one of these? Right? Resist that temptation, because this is not a factor of the top. There's a plus sign right here. This is only a factor of part of the top, so it doesn't cancel with the bottom. Okay. Anyway, there's the sine and cosine. Any of the rules that we already have still apply, and the sine and the cosine derivatives fit right in. They work very nicely with all the rest of them.